Hello, and it's your boy, welcome, and we are back at it again with another video. Today we are going to be learning how to differentiate composite functions. What is a composite function, you ask? Well, a composite function, put quite simply, is just a function that is inside a power. Okay? It's that simple. For example, let's say I have the, oops, let's say I have the function y is equal to 2x plus 3 to the power 6. You have a function, 2x plus 3, and it's inside a power, and in this case the power is 6. So how would you actually differentiate this function? Well, the same techniques apply. We drop the power, we decrease it by 1, but then we do another thing. So what you simply do in this case is, let's say we want to find our dy dx. What are we going to do in this case? Well, we're going to drop down the power, and then we're going to decrease the power by 1, but then we are going to multiply this answer. Remember, this big blob that I'm putting here, it just means multiply. I don't want to put an x because some of you confuse it with the x that I'm using for my x's. The x that I'm using for the x's inside here. So anyways, same technique apply. We drop down the power and then we decrease it by 1. So we drop down the power and it now becomes 6, and it's now 2x plus 3, and then we decrease the power by 1. 6 minus 1 is 5. But we don't end there. We are then going to multiply this by the derivative of whatever is inside. Okay? So when you look at 2x plus 3, what is the derivative of 2x plus 3? What is the derivative of 2x plus 3? If you're quick enough now, the derivative of 2x plus 3 is just 2. This is a constant. When you differentiate this constant, it just disappears. It becomes 0. When you differentiate this 2x, you're going to get 2. So then you're going to multiply this by 2. And that's it. Simplifying this, you're going to get 12 multiplied by 2x plus 3 to the power 5. And that's all you do. And we're done. That's how you differentiate a composite function. Yay! It's actually quite simple. So a composite function is whenever you have a linear function inside the power. Now I need to clarify the concept linear function. If you were to differentiate 2x squared plus 3x plus 4 to the power 6, you're not going to do this. You can't differentiate this. This is inappropriate. It's a taboo for you and I at this moment in time. The function that is inside has to be linear. What that means is the highest power of x should be 1. Okay, we can't have any other power, 2, 3, 4, 5, whatever. We can only use this technique if the highest power of x is 1. So, you know, that's just a rule. I can't tell you anything further than that. I can't tell you anything more. So let's look at another example. Let's say we have g of x is equal to 4x plus 1 to the power 3. And let's say we want to find our g prime of x. What do? We drop down the power 3, 4x plus 1 squared. Big blob for multiplication. So you drop down the power of 3, and then you decrease the power of 3, it becomes 2, and then you multiply by the derivative of the inside function. The derivative of the inside function is just 4. And this is going to give us 12 multiplied by 4x plus 1 squared. And that's all you do. Anyways, that's all. That's all you need to know on how to differentiate composite functions. It is quite simple. It's very, very simple. You're combining the techniques from the previous videos of dropping down the power, decreasing it by 1. But in this case, you then multiply it by the derivative of the inside function. Anyway, we've come to the end of this video. Please, if you enjoyed the video, smash that subscribe button, like the video, leave a comment, press the notification bell, share the channel, and as usual, take care.